We're going to do one example here with uniform circular motion, and I just think this is good to get, again, a sense of sizes of things. So here's the case where I have, this is Eckert's traffic circle as seen in Google Maps, and the reason I did this is that I want us to estimate, so here's our problem, estimate your acceleration that's towards the center when you go around, when we go around the traffic circle. Okay, so first of all, we're going to need the size of the traffic circle, and then we're going to need how fast you're going. So if we say that we, and so this, if I look at this scale, I sort of drew this on here, you can see this is about here, so we can call the radius approximately 20 meters. So Google Maps tells us how big it is. And then we can say our speed, let's say we're going, I don't know, something like 20 miles per hour. And then we have Google tell us the conversion there. 20 miles to meters per second. And that gives us, let's call it 9. That gives us about 9 meters per second. Otherwise, we're going to have kind of weird units. If we have r in meters, but then our velocity in miles per hour, that's kind of a weird combination of units. And so our acceleration, the direction is towards the center. There's the center. Sorry, I said we would estimate it was 8.9. We're going to call it 9 meters per second. And the magnitude of it is just v squared over r, which is 9 meters per second squared over the radius, 20 meters. And we can check our units. So this is 81 meters squared per second squared over 20 meters, or about 80 divided by 2, about 4 meters per second squared. So that's our acceleration if we really go around it at 20 miles per hour, which maybe is not what you want to recommend, but that's a way you can get that. The other thing you can do if you want to find this speed, notice you can do one other thing because it's a constant speed. You can also estimate the time it takes you to go around. I realize when you're driving, it's really easy to know your miles per hour, but if you want to know, for example, if you're biking around the traffic circle, then if you want to estimate your speed, you can say your speed is the distance you go, which is the circumference, 2 pi r, over the time to make that circle, which we usually call a period of revolution. And so that's another way you can find your speed when you're going around a circle. And so that's a useful thing to hold on to, the circumference divided by the time, because sometimes that's easier to estimate.